Hello everyone, I am Bhagya Rekha, Assistant Professor in the Department of Computer Science and Engineering at VIGNAna JYOTHI Institute of Engineering and Technology. In this lecture, we will discuss the introduction to software engineering and its key characteristics. Let us start learning the software engineering. So, before we learn software engineering, let us understand the term software and engineering individually. So what is engineering? Engineering existed since ancient times, like when the early man invented the wedge, lever, wheel, etc. The term engineering is derived from the word engineer. It seems like engineer means who builds the siege engine. And coming to the definition, let us look into the slide about the definition. The creative application of scientific principles to design or develop structures, machines, works, utilizing them singly or in a combination. So, to construct or operate the same with full cognizance of their design or to forecast their behavior under specific operating conditions. So, if I have to give a definition about the computer science engineering, because the software engineering comes under computer science engineering. Computer science engineering mainly contains variety of topics that relates to computation, like analysis of algorithms, programming languages, program design, software and computer hardware. So, if I have to do the postmortem of the definition, we already learned about engineering and computer science engineering. If I look at the software, the definition of the software is instructions that when we executed provide a desired features, function and performance. Data structures are the one that enable the programs to adequately manipulate information. And documents are also part of software and that describe the operation and use of programs. So let us look into the next slide and try to see what I have explained. So the pictorial view of this diagram explains what I have explained till now. It is the software contains mainly three components, like instructions that has features, functions and performance, and coming to the data structures, those are the one that manipulate information and they describe operation and use. So in general, if I talk about the hardware, actually it refers to the physical part of a computer other than software which we have discussed till now. And it also contains many tangible parts where you can see, touch them and use them, and they also work in conjunction with software. And these software are nothing but the programs and instructions where we use them to get our tasks done and preferable operations that are requested as part of application. So, and there is in general definition of the hardware also is mentioned here in our presentation, which refers to the physical components or parts of any device or machinery. And also coming to the operation, it has some tangible objects where it can be a computer or a car or any electronic or mechanical device that is participating in that hardware operation. So the diagram here, you can see the various tangible objects that I have discussed till now. So one of them are input devices, keyboard, mouse, scanner and microphone, and output devices also that are there. Some of the examples mentioned here are monitor, printer, speakers, and we have processing devices like CPU and GPUs. We have some storage devices also coming from HDD to USB drives, network devices and peripheral devices like webcam, game controls. Based upon the usage and need, you will be using the same. So let us move to the next slide where I will be talking more about the history of the software engineering, I would say, if I have to put it in a overview. So this era has started from 1940s to 1950s, where we call it as hardware driven era, and we have most of the custom hardware solutions. So here in the bubble that is related to the hardware driven era gives the high level overview of those details, that we have early computers like ENIAC 1945 where we used hardware like vacuum tubes and punch cards. And these computers are very large. They used to occupy big rooms and they're very expensive and they're like task oriented. The next era that you look into the second point, that is emergence of software stored program concept. Here, 1949, these stored program concepts came into picture, and they have allowed the computers to store some instructions in their memory, which we will be executing. And slowly the programming languages came into picture, that is Fortran, that came in 1957, and we have COBOL that came in 1959, and these were made written instructions easier. Like we started adapting to the programming languages, if I have to put in simple words. So let us move to the third one, that is software centric developments. Here operating systems came into picture. So IBM OS 360, they came in 1964. Multiple resources can be managed using these operating systems, and slowly we have programming languages like C, which came in 1972, that made coding faster. And even till now, as a basic programming language, we started learning programming C only. And businesses also started using software like spreadsheets at that time. In 1979, businesses started using these things. And coming to the fourth one, this era started like 1980s to 1990s, where we have a bigger shift, where the users started using the computers, and we can make a word like personal computers. So here IBM started bringing these computers, personal computers. They became common, they're easy to use software, and the internet also started growing in this era only. And finally, the era that actually most of the generations are existed, like 2000s to the present one, we call this era as modern era. Here hardware became a platform, where we started with hardware driven as an era, and now hardware became platform, and we have smartphones that came into picture. Like iPhone is there nowadays, we are using various other brands also like Android and everything, and cloud computing. All these things, they reduced hardware dependency, and we have AI and other apps also that handle tasks which are previously done by complex hardware components. So this slide wholly talked about the history of the software, how it has shifted into various transforms and everything. So now moving to the software engineering, the definition, the actual one that we are trying to understand. So it is defined as the process of analyzing user requirements, and then we'll be designing, building, and testing the software application which will satisfy those requirements. So there is a one more definition as per IEEE. It is like it is defined as an application of systematic discipline, which is a computable approach for the development, operation, and maintenance of the software. So what is the practical application comes here is, we will be practically applying the scientific knowledge to create a design and building of computer programs, which also includes associated documentation, which is needed for developing, operating, and maintaining them. So this slide briefly talks about the software definition and understanding in a different perspective, like application of the scientific knowledge. So next, moving to the other slide, obviously we have talked about the definition. Now we'll try to understand what are the characteristics of the software engineering. So mainly there are three characteristics. So first one is, the software is developed or engineered. It is not manufactured in the classic sense. The second one is, the software doesn't wear out. Although the industry is moving to the component based assembly, most of the software continues to be custom built. So that is the third characteristic of the software engineering. So now let us try to understand these characteristics in an elaborated way. So coming to the first characteristic, that is, software is developed or engineered. It is not manufactured in the classic sense. So this characteristic, we try to understand this by comparing with the hardware, because we already seen in the history where we started with the hardware era and we ended up with the hardware as a platform. So when we have to understand the software development, then it is better to compare the software and hardware to understand the things in an easier way. So the two activities of software and hardware both are different fundamentally, even though development and manufacturing of software comes as development, and coming to the hardware, we call it as hardware manufacturing. Even though both of them have a similarities that exist between them, but in both activities, through a good design, you can achieve high quality. But the manufacture phase or the hardware, when it comes to the manufacturing, it can introduce quality problems that are non-existent for software. So both these activities require the construction of a product, but the approaches are different. So if you see here, the slide talks about or provides the snapshot of hardware manufacturing and also the software development. But in hardware, the manufacturing defects like the broken chip or any wire loosening, all these things can cause during the production due to some kind of manual error or any kind of error, because these physical parts are made in factories and also the integration takes place. But coming to the software, we talk about planning, designing, and coding, where hardware obviously it is talking about the physical manufacturing. In software, there is no physical production. Instead of the quality issues that arise from poor design or coding mistakes, but these can be fixed before the release itself during the testing phase. So let us talk about the second characteristic, that is software does not wear out. So to understand this, let us take an example of hardware appliances that we are using in the day-to-day life, like fridge, mixie, or microwave oven. So when we use these products like harshly or roughly, or if we are using them for the long time, then they will be no longer in good condition or working order. But during the life of the software generally undergo changes at that time, and it will go different changes. So the failure concept in the hardware and software can be understood by using the graph, the bathtub curve, for understanding the failure rate of the hardware. So this is the one that you are looking at is the idealized curve for understanding the software curve. So if you are looking into the presentation, you are looking about the failure curve that I'm going to talk about. So this curve is generally used to understand how the hardware run to the failure, maintenance strategy, or reliability of the assets. And these assets are usually equipment like components or parts of the equipment, etc. This graph is used to identify root causes and predict when the failure usually happens. So there are three different sections of the curve in the bathtub curve. They are like infant mortality, normal life, and wear out. So let us look into these sections and understand them. So the first comes the infant mortality section. If we take an asset and if it fails because of the manufacturing defects, installation issues, design issues, material defects, etc. Because of these manufacturing defects, let us say for an instant, then the asset falls under this infant mortality section and is simply referred as, we can term it as like early failure period. Here the probability of failure occurrence is very high and gradually decrease in failure rate with increasing time. So the next comes is the normal life section. We can also call this as usual life period or steady state operation. To understand in detail, we can say the failures are usually occurred due to overloading, hidden facts, etc. Failure occurrence like generally depends upon function and condition of particular asset. Therefore, for different assets, failure rate can be different. So failure rate is almost constant in this space, and here the failure generally occurs due to random events. The last phase is like wear out section, and this section is nothing but aging period And by seeing this curve, we can say that there is gradual increase in failure rate of asserts with increasing time. So here the failure of assert occurs because of the fatigue, like gradual deterioration, and this period represents the end of life cycle of asserts. So now let us move to the next slide and try to understand the graph for the software. So here the software generally does not go through the environment problems which we have observed in the previous slide, that is hardware life cycle. Therefore, we cannot use the same curve to understand the software failure rate. In software, we will have undiscovered defects that can cause the software to have a high failure rate early in the life of a program. But if we have done the proper testing and if these defects are fixed, then the curve flattens as shown in the graph. So by this observation, we can say that software does not wear out, but they deteriorate with maintenance. Like we see the mobile, which gets automatically updated whenever there is an updated version from the vendor. And when these new changes are deployed, then we might introduce some defects as well. So because of these, the failure rate curve will spike as shown in the graph. So when the bugs are removed or fixed, again the curve can return to the original steady state. Like this, we can say that whenever the changes are requested, then the curve spike again. Slowly, the minimum failure rate level begins to rise. The software is deteriorating due to change. So this is the graph about the failure rate. So one more difference between hardware and software that can be observed is when the hardware wears out, then they can be replaced by spare parts. But coming to software, there will be no spare parts for it, because if there is a failure, then it is because of error in design or in the process through which the design was translated into the machine executable code. So based on this, we can say that software maintenance involves considerably more complexity than hardware maintenance. Next, coming to the next slide, we'll try to understand the third characteristics of the software engineering. That is, although the industry is moving towards the component-based construction, most software continues to be custom built. To understand this characteristic, first we will understand how the hardware configuration will be done. So the design engineer here, he draws a schematic view of the digital circuitry and will do a kind of analysis to ensure that proper function will be achieved. Once the design is done, then he will have a catalog of digital components, and each integrated circuit has a part of number, like it will have a part number and a defined validate function. Then following the integration guidelines, each and every component is selected or they will be ordered off shelf. And mostly these components will be standard screws and integrated circuits that are used by most of the mechanical and electrical engineers. Mostly they reuse these items because their concentration should be on innovative elements of the design. But now let us look into the software development here in the slide. The main objective of software component is to implement a functionality or set of functionalities, and also it should be or can be used in many different programs. Nowadays, the reusable components are encapsulated like how we have in hardware component, where the sole intention is to go for innovative ideas but not building the items from scratch which already exist. In the same way, in software also, if we take an example of user interfaces which are wide variety and have lot of features, but these are built with reusable components that enable the creation of graphic windows, pull down menus, etc. So in this video, we have tried to understand the introduction of software engineering and its characteristics. Hope you have understood and enjoy learning these concepts of software engineering. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.